dry clothes. The first balloon, you rubbed it on the dry clothes. The second one, you rubbed it on the dry clothes. You now notice that the two balloons now became positively charged. The two of them became positively charged. So they are asking now, what charge do you think these balloons have transferred to the clothes that they rubbed?
A positive charge.
Why do you think it's positive charge?
Because it's not in the question.
It was the balloons that became positive charge. Okay, so let me explain how to know.
So that means the cloth. That means the cloth is negatively charged, so they're taking away all the positively charged.
Okay, look at this. Good. You're making a point, but look at this. Balloons normally are not charged. They are not charged. This pen I'm holding naturally is not charged. It's neutral. It's plastic. It's neutral. To be neutral means it has equal amount of positive, equal amount of negative. It doesn't mean it has no positive or negative at all. When you say something is charged, what it actually means is that it now has one particular charge more than the other. If I say that the balloon is positively charged, in theory, they just draw all the positive charge inside the balloon. But in the reality, it doesn't mean that the only charges inside this balloon are positive. No, it means that there are more positive charges and fewer negative charges. So the one that is more is the charge of that particle. So the balloon, at a normal case, before it was rubbed on the clothes, is neutral, meaning that, let's say, 4 positive charges, or let's just say, okay, 4 positive charges, right? Before we rubbed it on the clothes, it has 4 positive charges and 4 negative charges. This is the meaning of neutral. Equal charges. So nobody is winning anybody. They are balanced. That's the word neutral. So the effect of the positive charges balances the effect of the negative charges. If you don't understand that. Now look at, we have this box. A rope was tied here. Another rope was tied here. A boy was trying to drag this box, applying a force of 50 Newton at this side. Another boy was also trying to drag this box, applying the same force of 50 Newton at the other side. Can you tell me, Chimamanda, what direction do you think this box will move if the both of them are pulling it with the same 50 Newton at the same time?
It's not going to move.
Thank you. So it's not going to move because the resultant force is 0. Resultant means the 50 minus 50 equals 0. There will be no effect. In other words, we say that this force is neutral. That's the word. If they have neutralized each other, they canceled out the effect of each other. The same thing I just explained is the same thing that applies here. Every charges, they usually act on each other. Look at the question.
Yeah.
They said, I just told you what it means. Initially, before the balloon were rubbed on a cloth, they have equal positive, equal negative charges. That means they are neutral. But by the time we were done rubbing the balloons on the clothes, they became positive. Now I'm asking you, which charge do you think have been kicked out from the balloon?
The negative charges.
Thank you. So negative. So now you see exactly what I told you. The balloon has positive, negative, positive, negative, positive, negative, see, equal. That means initially the balloon was neutral. can see that exactly what I explained is neutral. The shed itself, positive, negative, side by side, you see, they are all neutral as well. I now brought this yellow balloon close to this. I rub it. Do you observe? Can you see now that we still have 4 positive charges and many negative? Where were those negatives coming from?
Cloth.
The negative, where did they come from that entered into the balloon?
They came from the cloth.
Now, what do you think has happened to the clothes? In terms of the charges, what happened to the clothes?
There are more positives than negatives.
Thank you. So if I want to ask you, this clothes is charged. Is it charged now? Is this clothes charged?
Yes, it is charged.
If it is charged, what charge is it?
It's a positive charge.
Or negative? Positive. Thank you. So forget about the fact that you can see some negative charges around it. No, it doesn't matter. What matters is that which of the charge is more. The one that is more than the other one is the charge of that particular material. So we have more positive, fewer negative. So I can say this shed is now positively charged. The balloon, fewer positive, more negative. This balloon is now negatively charged. So you see, in the initial case, the both of them were neutral. But while rubbing the balloon now became negative. The exam is now asking you that if the balloon is negative now, what does it mean? It means that the shed has transferred electrons to the balloon. Now, another point I want to make clear here, let me reset this. See, this is one point some teachers, or let's say most teachers, do not explain to students. Positive charges are never transferred. Can you ask me why? Let me be sure you are interested to know why. Now, the reason is this.